This tool is an addition to an existing tool of a client. The tool is creating additional components to a freeform cladding system that the client produces that is using air-filled pillows. It's creating two aluminum profiles that hold these pillows. To start the tool, you have to load the data that got created by the original tool and that's stored in dictionaries in the drawing. Then you have options to define the design of the nodes. You can define the gaps between the parts. You can define the diameter of holes that are in the nodes, and you can define the minimum edge length of the cover profile. You can also set if you want to split the parts in the middle, the parts that get created, and you can define as a general setting if you want to have for the regular nodes, the nodes that are in the inside of the freeform net, if they should have holes in the base and holes in the cover, and also for the border nodes, the nodes on the outside of the net, if they should have holes in the base and holes in the cover. I'll start the creation of the parts. AP systems created that says that the dictionaries that the original tool created got analyzed. AP sections are loaded. The sections of the new profiles are loaded from drawings, and the tool is starting to create the profiles. It's pure AutoCAD, so the parts are created as solids, and with the creation of the parts, the geometry of the parts is also analyzed and stored in the dictionaries. The tool has an option to export the data, that is the production data that's stored in the dictionaries, into Excel lists, and that can be accessed. And the data that's in the Excel lists, that's bill of materials, and the production data can get loaded into the production drawings of the client. The creation is done. Let's have a look. We see that we always got two profiles created, a cover that's green here and a base profile that's orange. We also see that according to the setting that we have a hole in the center of the node, a hole both in the base profiles that has a diameter of, it's set here, 40, and we have a hole in the cover profiles that has a diameter of 50. Some of the parts have a different color, like the parts here, and the reason is that the tool is checking for the cover if the minimum edge length, that's the length here, is met, is 12 millimeters. And if that's not the case, then the tool is reducing the cut from the center of the node, the cut of the cover profile, until the edge length definition is met. The color of the cover profile that's showing, that the criteria are not met completely. The color depends on the side where the problem occurs. So if it's on the start side of the profile or on the end side. And the start side of the profile is always the node that has the lower number. I'll hide the cover profile now so that we have a better look at the base profile, and we see there are also a couple of profiles that have different color, not orange, it's blue. And the reason is that the tool is checking if the cut of the profile at the end is cutting the nose that's holding the pillow. And if so, it's also reducing the distance to of the cut from the center of the node, as we see here. So the hole is not 40 millimeters altogether. The tool has options to edit the parts, to edit created parts. I'll show it with one set of profiles. I select this profiles, and what I can do, for instance, is I will turn on the covers again. I can delete the split points, and what else? For instance, I could say don't create holes in the base and don't create holes in the cover. And if I recreate the part now, what we see is sections are loaded. We see the splits are gone, and also the cuts at the end of the profiles don't exist anymore. There's also the option to set split points to the parts. I'll do that. I'll set split points here. I have to select points on the system line. I'll do that, one here and another one here. And I say enter, and we get two sets of split points. And because this applies symmetry rule is set, the offset to the split point of the split points of the cover is to the inside. That always applies if the number of the parts that get created is uneven. I'll create holes in the base and holes in the cover again, and I recreate the part, and let's see what's happening. We have splits here. We got 2 times 3 parts created, and we have the holes at the nodes again. Exporting the created data to Excel lists, I have to select all parts that I want to export, whose data I want to export, and now the data that got created and that got stored in dictionaries is read from the dictionaries and is exported to Excel lists. So the Excel list for the base profile got created. We have to save it. We save it to Freeform AP01. Yes, and now the tool is creating the Excel list for the cover profile. The Excel list for the cover profiles, we also save it. And we open the Excel lists right away. The Excel list for the cover. And if we look at the lists, both lists have a bill of material part that has the position number of the parts, and if we look, we have, and that is the cover, we have about 300, 400 cover profiles, so it will also be 400 base profiles, 800 profiles altogether that the tool created. And we have the names of the section, and we have the length, material, unit weight, etc. And if we look at the production data, we have all the geometric data that is needed to fabricate the parts. For the cover, we also have the quantity of the holes and the distance of the holes that are needed to bolt the cover to the base profile. This fabrication data table will get loaded into the production data drawings of the client. Let's look at the base profile. There we also have the BOM part with the position numbers for all parts, and we have the section, and we have the length, material, and we also have the weight. If we look at the fabrication data, there is also all geometric data that's needed to fabricate the parts. In addition, there's the number of the start node and the end node of the part, and then there's also added if the profile is an edge beam, yes or not, and if it's an edge beam, on which side of the profile the weep holes should be. So that's automated AutoCAD solid modeling and editing. If you want to see other tools that we made, or if you're interested to get a tool customized to your needs, please have a look at our webpage. There you will also find contact information.